Introduction. We have many things around us. All of them have some properties such as shape, size, color, composition, structure, etc. Due to certain reasons, there are alterations in properties of things. Such alteration is called change. Any of the above properties may change. Some of the examples of changes are melting of ice, change of state, cooking of food, change in state, odor, etc. Rusting of iron, change in appearance, color. Growing of hair, change in size. Can some changes be grouped together? In this chapter, we will learn classification of changes on the basis of some similarities between them. Can all changes always be reversed? Some of the changes can be reversed, whereas some other cannot be reversed. On the basis of this, changes can be classified as reversible changes, irreversible changes. Reversible changes. The changes which can be reversed to form original substance are called reversible changes. In reversible change, the identity of substance does not change. Some of the examples of reversible changes are melting of ice. When ice is heated, it melts to form liquid water. A change from solid to liquid takes place. Now, if we cool water to form ice, it again changes to solid ice. A change of state from liquid to solid takes place, but composition of water is same. Thus, melting of ice is a reversible change. Melting of wax and burning of a wax. Take a porcelain dish. Put some wax into it. Heat it over a burner. On heating, wax starts melting to form a liquid called molten wax. Change of state takes place from solid to liquid. Now, remove the burner and allow the wax to cool. On cooling, wax becomes solid again. Again, change of state takes place from liquid to solid. Physical change. Activity 1. Cut a piece of paper in 4 square pieces. Cut each square piece further into 4 square pieces. Lay these pieces on the floor or a table so that the pieces acquire the shape of original piece of paper. Activity 2. Take some ice in a glass tumbler. Melt a small portion of ice by keeping glass tumbler for some time. Now we have mixture of ice and water. Now place the tumbler in a fridge. Melted ice again becomes solid ice. Activity 3. Hold a used nail with a tongue. Keep the tip of the free end of the nail on the flame of a burner. On the flame, it becomes red. Wait for some time and then remove the nail from the flame. On removing, it will get back to its original color. All these activities shows change in color, state or shape of a substance, which is temporary and no new substance is formed. Properties such as color, size, shape, and the state are physical properties. Any change which involves a change in physical properties is called physical change. A physical change is generally reversible. No new substance is formed in a physical change. Chemical change. Chemical changes are very important. In a chemical change, all new substances are formed as a result of change. Heat, light, or any other radiation, ultraviolet for example, may be given off or absorbed. Sound may be produced. A change in smell may take place or a new smell may be given off. A color change may take place. A gas may be formed. Examples: extraction of metal from ore, explosion of fireworks, digestion of food, formation of medicines. Chemical change. Examples: Activity 1. Get a small piece of thin strip or ribbon of magnesium. Clean its tip with sandpaper. Bring the tip near a candle flame. It burns with a brilliant white light. When it is completely burnt, it leaves behind a powdery ash. The change can be represented by the following equation. Magnesium plus oxygen gives magnesium oxide. Test the mixture with blue and red litmus papers. Red litmus paper turns blue. So, magnesium oxide is a new substance formed on burning of magnesium. Rusting of iron. Rusting is a chemical change. When iron is exposed to atmosphere, it reacts with air and water and acquires a film of brownish substance called rust. This process is known as rusting. Rusting affects iron particles and slowly destroys them. The process of rusting can be represented as iron plus oxygen plus water gives rust, that is, iron oxide. For rusting, the presence of both oxygen and water or water vapor is essential. Rusting is directly proportional to moisture content, that is, if moisture content is high, rusting is faster. Prevention of rusting. Rusting can be prevented by following methods. Painting or oiling. To prevent rusting, a coat of paint or oil is applied over the iron article. By doing this, direct contact of air and water is prevented. Electroplating. We can protect rusting of iron by electroplating of nickel or chromium. Galvanization. It is a process in which a layer of metal like zinc or chromium is deposited on iron. Iron pipes in homes to carry water are galvanized to prevent rusting. Alloying. Iron can also be protected from rusting by converting it into a alloy such as stainless steel. Alloys are homogeneous mixture of a metal with a metal or a non-metal. Crystallization. Crystallization is the natural or artificial process of formation of solid crystals precipitating from a solution, melts or more rarely deposited directly from the gas. Pure copper sulfate is dissolved in minimum amount of water to form a solution. The solution is then filtered to remove insoluble impurities. The solution thus obtained is heated gently on a water bath till a concentrated solution or saturated solution is obtained. Allow the solution to cool slowly. Crystals of pure copper sulfate are formed.